Let's move on to integral calculus. And integral calculus is going to focus on the area problem. And it says the limit process can be applied to find the area of a plane region bounded by the graphs of functions. So here's our function y equals f of x. And we can actually find the area under this curve using integral calculus. And if we consider the limit process like we did before, we could actually break this up into rectangles and find the area of each of the rectangles and add them up, and that's an approximation. And we can see that as we increase the number of rectangles, that we're going to get a much closer approximation. So for an example, consider the region bounded by the graphs of f of x equals x squared, y equals 0, and x equals 1. And we want to approximate the area of the region first using 4 inscribed rectangles. So here's the region that we're looking for. And if we're going to do inscribed, we're going to go from 0 up to 1. All right. And so our first rectangle is just going to be underneath and actually has no height. And our second rectangle is going to go up to this point and then over. Our third rectangle will go up to this height and then over. And then our fourth rectangle will go up to this height and then over. Okay, now what we can do is add up the areas of all these rectangles, and we're going to get an approximation of the area under the curve. Well, if we look at this, we're breaking up 0 to 1 into 4 equal parts. So we can do 1 minus 0 over 4, and that gives us 0.25. Or 1/4. So we know the widths here are 0.25 each. Okay, now to find the area of a rectangle, remember we just need the height. Well, here, this is the height at f of 0. This is going to have the height of f of 0.25, because that's the x value here, and we know the height of the curve is the function at that x value. This one's going to be f of 0.5, because we just tacked on another 0.25. This will be height of f of 0.75. So now that we've found our widths and we know how to find our heights, let's go ahead and find all the values of our heights. Okay, so f of 0 is actually going to equal 0. F of 0.25 will be 0.25 squared, which is 0.0625. F of 0.5 is going to be 0.5 squared, and that gives me 0.25. And f of 0.75 is going to be 0.75 squared, which is 0.5625. So now we can find the area of each of the rectangles. So our first one has a height of 0 and then a width of 0.25. Our second rectangle has a height of 0.0625 and a width of 0.25. Our third rectangle will have a height of 0.25 and a width of 0.25. And then our fourth rectangle is going to have a height of 0.5625 and a width of 0.25. And if we multiply all this in our calculator, we get an approximation of 0.21876. And this is going to be definitely an underestimate because we are underneath the graph. So let's go ahead and approximate here with 4 circumscribed rectangles. And so this is going to mean the outside. So now if we're going to go from 0 to 1, we actually want to go rectangles above. So now let's split it into 4s. And again, we know everything's going to go on the 0.25s. So we got 0.25, 0.5, 0.75, and now 1. So now we're going to start here and go up this way. All the way up to there. Okay, now we can find the area of these 4 rectangles, and so our heights, okay, some of them we can reuse. We're going to need f of 0.25, which we know is 0.0625, we need f of 0.5, which is 0.25. We need f of 0.75, which is 0.5625. And now we also need f of 1 for our fourth rectangle, and that's just 1 squared, which is 1. Now if you noticed here, each of these got multiplied by the width of 0.25. So we really could have just factored that out in approximating our area. So our area is going to equal 0.25 times the sum of all the heights here. So 0.0625 plus 0.25 plus 0.5625 plus 1. And when we do this into our calculator, we're going to get an approximation of about 0.46876. And this is an overestimate because you can see the rectangles are above the line. So we know our actual answer is somewhere between here and here. So we could take the average of the two, putting this into our calculator, we get 0.34376, and that would be a good approximation of the area under the curve. Now, just like with the tangent line problems, as we increase the number of rectangles, we're going to increase our accuracy of our approximation. So let's go now to 5 inscribed rectangles. So what we want to do is find the width of each rectangle first, and that's going to be 1 minus 0 cut into 5 equal portions, which is 1/5, or 0.2. So if we label all of these here, we're going to get 0.2, 0.4, 0.6, 0.8, and 1. So let's go ahead and deal with our inscribed rectangles first. Okay, so it'll be that one, and this one, this one, this one, and one more. Okay, so you can see here are our 5 rectangles, and here are the x values for all of our heights. Actually 0, 0.2, 0.4, 0.6, and 0.8. So let's go ahead and find our heights now. So it's going to happen at f of 0, which is 0 squared, which is just 0. It's going to happen at f of 0.2, which 0.2 squared is 0.04. It'll happen at f of 0.4, which is 0.4 squared, or 0.16. It'll happen at f of 0.6, which is 0.6 squared is 0.36. And the last one will be at f of 0.8. And that's going to be at 0.8 squared, which is 0.64. All right, now if we're going to find the area, remember we can take our width of 0.2 and multiply it by our sum. So if we add all these up, it actually gives us, let's see, 0.2 and then 1, so that's actually 1.2. So our area is going to be 0.2 times 1.2, which is 0.24. Okay, and you can see here that this is a little bit better approximation than with 4 rectangles, and you can see that the area is a little bit closer. So let's go ahead and find 5 circumscribed rectangles. Again, we're going to have this here 0, 0.2, 0.4, 0.6, 0.8, and 1. And so now we want circumscribed, so we want the rectangles above. All right, so there are 5 circumscribed rectangles, and let's go ahead and find our heights. So we're going to get f of 0.2, which again was 0.04, f of 0.4, which was 0.16, f of 0.6, which is 0.36, f of 0.8, which is 0.64, and f of 1, which is 1. So again, our area is going to be our width, which is 0.2, times the sum of all of our heights. So in this case, we have 1 plus 2 plus 0.2, and so that is 2.2. And so this area gives me about 0.44. You can see compared to 4 rectangles of 0.46876, which was an overestimate, now we're bringing it back down, getting a little bit closer. If we found our average now of these two, we would get a better approximation, so 0.44 plus 0.24 over 2, and this is about 0.34. And again, it's just an approximation. If we increased the number of rectangles to infinity, then it's going to give us an exact answer. And so that's what calculus is going to do. It's going to help us take this process of increasing the number of rectangles to find our exact answer. All right, so that is our preview of calculus, kind of what we're going to be going over in the next 2 semesters here.